Hey everyone, myself Anurag and this is my project Vector Forth Kernel, a custom x86-64 bare metal operating system that I built from scratch using C and x86-64 assembly. So this project includes a custom bootloader, a 64-bit higher half kernel, as well as physical and virtual memory managers, interrupt handling, a threaded code, Forth virtual machine, a persistent block file system, and SIMD accelerated vector operations. So in this demo, I'll show you the system booting, compiling new Forth words live, saving code to the disk, reloading it, and running vectorized stack operation directly on CPU SIMD registers. Now I will build and run the OS image. So let's type in the command. As you can see here, it successfully booted. Now we'll do some operations here. Now let's say we do some addition. 10, 20 plus dot. It returns 30. Now let's do some subtraction. Let's say 80 or 40 dot. It returns subtraction 2. Now let's say multiplying 2. Let's say 6, 9 star dot 9 6 of 54. As you can see, it returns operations too. Now we'll use a stack operation to see. First, let's say in a stack we store 69, 89, 46, and we store in this stack. As you can see, it is stored in the stack. Now we'll call out the stack dot s. You can see that it returns the stack too. So now we'll see the runtime compilation. Now what we're gonna do is we'll define a square function. Let's say square dub star is the operation, and then it ends. You can see that it returns okay. Now we'll call the function, and then let's say we use 9. What's 9 square? Now we'll use 9 square dot. As you can see here, it returned 81. Now we're gonna do some runtime compilations. Now let's say we'll use this is our square dub star, and now let's do some square 5 square. As you can see, it returns 25. Now we'll decompile this. We'll use the decompiler or dictionary introspection. Now let's type C square. As you can see here, square dub star. So here I implemented a decompiler with the C word SEE. This works the dictionary entry in memory and reconstructs the source level structure of the compiled word. So this is why Forth is a powerful in low level environments. The language compiler and runtime all live inside the same machine. Now we'll use the file system or editor demo. Now 5 edit. As you can see here, it opened the editor. Now we use this to define cube dub star star. Yeah. Now we press the escape button. Now it's back into the disk. Now in this here I write 5 load. Now we loaded the file. Now we'll do some cube. Let's say 7 cube dot. It returned the cube too. This means the operating system can extend its own language from persistent storage at any time. Now I will show you one of the most unique parts of this project, that is vectorized stack support. The kernel enables CPU assigned registers and exposes vector operations directly into the Forth language. Now, let's say I write 99. So the VGUP takes one scalar value and broadcasts it across the hardware vector register and then spills the result back into the Forth language. In this case, the value 99 is duplicated into a vectorized pair using 128-bit XMM registers. So that proves the SIMD backed stack operations are live. Now, let's say 10, 20, 30, 40 v plus dot s. As you can see here, instead of doing one addition at a time, it loads multiple values in the CPU vector registers and adds them simultaneously in one instruction. So v plus performs parallel integer additions on vector lengths. So here 10 plus 30 becomes 40 and 20 plus 40 becomes 60, all through SIMD execution here. As you can see here, 99, it was previously in VDUP and in the stack, and then we added here 10 plus 30 is 40, 20 plus 40 is 60. So now, to summarize, the operating system currently boots from a custom MBA, enters 64-bit long mode, runs a higher half kernel, handles hardware interrupts, provides a threaded code for the virtual machine, stores source code into a persistent block file system, and supports SIMD accelerated vector. So let's say now let's see the live part. Now we'll go to this one. As you can see here, my operating system loaded. Now let's say I type, let's do the same thing again. Let's call some stacks 456 dot s. It's stored dot s will return 456. Same with the, we'll do some file editor there. So we'll use 5edit. As you can see here, it's already stored there. You can see here the file editor, inside the file editor, whatever it is, it gets saved in the operating system and then it stays in the operating system. It doesn't delete itself. So as you can see here, it's already stored here. I already written it out before. So thank you for watching. This project was built entirely from scratch as a deep dive into operating systems, low-level programming language, and runtime design. So at this point, phase 1 to 4 are complete. Phase 4 5A hardware detection is complete, and for phase 6 128 SIMD is complete. So the next major steps is to implement the networking stack, improving Forth standard library, and potentially revisiting AVX 512 on compatible hardware.